This video is going to be about how to solve quadratic equations in another way. The previous video showed you how to do it with factoring. Sometimes factoring is not an option, so we use square roots to help us figure out what the x or the other variables are equal to. And in order to know how to do this, you're going to need to know how to manipulate things underneath roots or square roots, also called radical signs. So here are two properties. One states that if two numbers are multiplied underneath one square root, that you can split them up into two different square root problems. And you can also put them back together. So for example, we have like the square root of about 10. And so therefore this is equal to the square root of 2 times the square root of 5. So same thing. Our other property states that if there is a fraction inside one square root sign, that you may split the square root sign to the top and the bottom. So here's an example. If you had the square root of 3 over 2, then this is equal to the square root of 3 over square root 2. Just like that. So let's use those properties to help us simplify these. So 24. Let's split up 24 into some factors. Now, some of the factors you want to definitely look for are any factors that are also perfect squares, such as for 24, that would be 4 times 6. Now I could have chose 2 and 12. I could have chose 8 and 3. But none of those are as good as 4 and 6 because 4 is a perfect square, meaning that I can square root the 4 and make it into a normal 2 and put the square root 6 next to it. And this would be our simplified answer. Let's take a look at the next one. The next one, we could go ahead and multiply these together, or we could just split them up as I see them. So let's see, I have a square root of 2, a square root of 3, that's the 6. I also have a square root of 3 for the 15 times a square root of 5. And these two guys right here are going to make 9. So I have square root 2, square root 9, and square root 5. Why is it important to point out that 9? It's because the 9 is actually a perfect square which I can square root. So what do I end up with? I end up with a 3 from the square root 9, and then 2 and 5 are left over, so that's square root of 10. Simplified. Now let's look at the next one. Split up the square root for the top and the bottom. I can go ahead and square root the 16, that gives me 4, but square root 7 is just going to stay on top. And that would be my simplified answer. Now there's another thing we need to know how to do when working with these type of problems. It's called rationalizing the denominator. If I go ahead and I try to split this into two square roots, that'd be a square root 7 over a square root 2. Neither of these I can actually square root, and I cannot split them in the factors that will have perfect squares in them. So what I need to do is I need to get rid of the square root 2 much in the same way that those two square root 3's became a 9. The way to make this square root sign go away is to multiply it by itself again. What you do to the bottom, you must do to the top. So what I end up with on the bottom is square root 4, and on the top, square root 14. And this 4 is a perfect square, meaning I can go ahead and square root it, and square root 14 is left on top. And this would be our answer. That's called rationalizing the denominator. So let's try that again. Split this into square root 11 and square root 5. I end up with two numbers that are not anything that's factorable. They're both prime, and I can't square root either of them. They're not perfect squares. So we're going to have to multiply them by what is on the bottom, square root 5. And so I end up with square root of 25 and square root of 55. Square root of 55 is something I cannot simplify, but I can square root the 25 and make 5. So this would be my answer. So now we get into why this is important. If I look at this problem right now, no matter how hard I try this, it will not factor. So what I need to do is, let's try to solve it like a normal equation. That means do everything I can to make the x by itself. So the first thing I would do is minus 1 on both sides. 2x squared equals 16. And then I divide by 2 on both sides. X squared is equal to 8. And at this point, I need to get rid of that square. So what I need to do is I need to square root both sides. What I get is x is equal to positive or negative square root 8. Why did I put positive or negative? Well, when I think about it, I could have gotten the 8 by plugging in a positive or a negative number, because the square will eventually turn it back into a positive number. So whenever you do a square root to a problem, especially during solving, you need to put that positive or negative. But we know that this is not our final answer, because 8 is something that can be split up. It does have factors that are perfect squares. Its factors are 4 and 2. And we can square root the 4, but we cannot square root the 2. So my final answer is positive and negative 2 square root 2. Let's try that one more time for another problem. This time I have a fraction in front, so the way to get rid of a fraction is to multiply by its reciprocal, 3 over 1. Multiply by 3 over 1. My fractions are gone. Rewrite x plus 5 squared is equal to 7 times 3 is 21. 21 divided by 1 is still 21. So now at this point, before I can get to that 5, before I can subtract the 5, I'm going to have to get rid of the square. So this is the point where you square root both sides. And that allows me to cancel out that square. So let's rewrite the leftovers. There's no more exponent now, so it's x plus 5. And then a square root 21. Because I put square root, I have to put positive and negative. Now the 21 is made from a 7 and a 3. Neither of those are perfect squares, so I cannot simplify that square root 21 anymore. So now it's time to realize that I don't need these parentheses, and I can go ahead and subtract 5 on both sides. Let's clean that up. Now here comes the little tricky part. X is by itself now. Usually the way we like to write these is we like to write the normal numbers first, so our minus 5 or our negative 5. Then we put plus and minus, and then we write the square root number. This is the typical way we write these, so that we don't ever confuse the 5 for being under the radical sign. A lot of students will try to write this down, and then they'll try to write the minus 5 like this. And then they're not sure, well, is this 5 underneath this square root, or is it not? I'm not sure. So we do not like to write it this way. We like to write it the other way. So this will be our final answer. Okay, I hope this helps you out. If you have any questions, please go ahead and leave a comment or email me, and I'll get back to you and see you guys back in class.